Hello, everyone. Welcome to the Ultimate Logic Apps Best Practices Guide. You'll not believe what's just happened, that literally 20 seconds ago, they've done a fire alarm test in the building, but fortunately, it's just finished. Welcome, everyone. Really good to have you here. So many of you live both on StreamYard and live on LinkedIn. So we'll just do the intros, let a few more people join, and then we'll get into the meat of the presentation. So what we're going to cover today, we're going to do a bit of introductions to me and Dave. We're going to look at the problem space overall, just a very quick intro to that for people that aren't really deep into this topic. And then really what we're going to focus on is Logic Apps performance today. And then we're going to hopefully have a bit of time for Q&A. So the other thing is, please feel free to join us at Slido because there'll be some polls. So if you actually scan this QR code, you can then join in and be part of the, action, and we'd love to hear your opinions on Slido. Okay, speakers. So I've got Dave Phelps, who's a senior cloud solution architect at Microsoft. Dave, would you like to say a few words about yourself and what you kind of do in the integration Logic App space?
Yeah, sure. So I'm Dave. As Andrew said, I'm a cloud solution architect at Microsoft. Been at Microsoft now for about 7 years, and I specialize in the integration space on Azure. So that's typically services such as Logic Apps, functions, API management, Service Bus, and Event Grid. And I work with customers to help them on their journeys into the cloud. And as I said, integration is my specialist subject. So really pleased to be part of this webinar.
Great stuff. Thanks, Dave. And as for me, I'm obviously Andrew Rivers. I'm the CEO and co-founder of 345 Technology. Now you've probably heard of Microsoft, so we probably don't need to introduce Microsoft too much. But if you don't know 345 Technology, then we're the #1 integration partner on Azure. We do the full solution lifecycle from envisioning, designing, build, and support. We've got just over 30 people in the UK, and we're focused solely on the integration space. And we have a product that we call 345 Air, which is a rapid start footprint for Azure Integration Services, so you can get an out-of-the-box pre-canned integration infrastructure up and running in record time. And that's us. So talking a bit about Logic Apps Ultimate Best Practices. Now we are going to have more than one webinar on this because it's such a massive topic. We kind of realized that when me and Dave started putting this together, that there are so many different elements to Logic Apps Best Practices. There's monitoring and alerting, there's security, there's DevOps, FinOps for a start, but the one that everyone talks about first is performance. So we are going to start out of the box and we're going to talk mostly about performance today. One of the other things I would say as well is that there's, if you leave questions, you can leave questions on Slido, I believe, but if you use the comments on the webinar, we'll when we get to Q&A later, we'll go through those. So we probably aren't going to address questions as we go through. We've got Q&A at the end, and we'll address questions then. So looking at the problem space first, and we're going to just very quickly introduce where Logic Apps fit in the integration picture. So what is integration? The way I usually describe it is that integration is the movement of data between two or more systems. And obviously, since almost every organization has two or more systems that need data moved between them, effectively, almost every organization has an integration need. But not everyone recognizes it as a discipline in itself. And there is a tool set in itself, and there are products that address this space. But in terms of the capabilities we need for integration, obviously APIs, connecting things together, that's a key part. Workflow is a key part. You've got messaging, event handling, streaming data, and the ability to embed code and logic in there somewhere so you can actually do some work. So those are the main capabilities that underpin integration. But in terms of Azure and the Azure product stack, as Dave said, he reeled out the product set, which so obviously APIs are covered by API management. Logic apps actually cover a few things because logic apps can be exposed as APIs. They can connect to APIs and they can do workflow. So logic apps are a bit of a Swiss Army knife in the integration tool set. And obviously, event grids help us handle events. Event hubs is a Kafka compatible streaming data. Service bus helps us deal with messages. Data factory helps us deal with large quantities of data, and often for reporting and BI purposes. And then Azure Functions allow us to write serverless bits of code that encapsulate business logic. So in terms of the overall integration space, there's a suite of services provided by Azure, and we are really focusing on logic apps that do a lot of the heavy lifting in this space. So without further ado, you can rescan the QR code, but got a little bit of a poll here. So, please join in the poll and just let us know if you're using Logic Apps Standard, if you're using consumption Logic Apps, are you using both, or are you using neither? You should be able to see the code there. Okay, we'll start to get some results in. Interesting. We'll keep very interesting that a lot of people are using both. We'll talk a little bit about this in a second. Okay. Well, thanks everyone. I'm going to move on in just a second. So get your final votes in now. And it's really interesting actually that there's so many of you using both. Also interested that for all of you who are using neither, then really glad to have you aboard, and hope you really get something out of this. So let's just move on. So I'm going to talk about Logic Apps performance, and really what we're going to cover in here: stateless versus stateless. We're going to cover built-in connections against managed connectors, synchronous versus asynchronous. We're going to look at the effect that number of actions has. We're going to look at scaling, and we're going to look at the relationship between Logic Apps and workflows and what that does. So again, back on the poll, next poll, hot off the press. Please let us know whether you are experiencing any performance issues on Logic Apps. Because if you are, then this is definitely the webinar for you. And if you're not, I'm glad. But again, just give you another minute to get some answers. It's already looking really interesting. And again, if hopefully by the end of this webinar, you'll have a lot of actionable things you can do to maybe address some of those performance issues. And if not, then people like me and Dave are around to help have a chat to, so that you can then take that away and improve that. But overwhelming majority are having some performance issues. So let's draw a line on the poll there. Thanks so much for responding, and we'll move on. Okay, so factors for performance. Performance really, I mean, in the world of computing, clouds move things on, but ultimately it still boils down to the same things. You've got CPU, you've got memory, you've got disk I/O, and you've got network. The difference between moving things into the cloud is that a lot of things behind the scenes actually talk via HTTP, so you have a lot more network, but it's a lot more easy to scale out CPU and memory. But every piece of technology is built differently. So the way that Logic Apps are put together, you have a hosting plan, which is, effectively it's an app service. It's behind the hosting plan are virtual machines that are running your your logic apps, and they can scale out. So you can set limits of minimum and maximum on those for scaling, and you can also set the size of the CPU. And then you, on that hosting plan, you host logic apps, and a logic app, and we're talking logic app standard here rather than consumption, but a logic app can host multiple workflows, and then you can treat that as a unit of deployment. You develop a logic app and you deploy that onto a hosting app, onto a hosting plan, and you can deploy multiple logic apps onto a hosting plan as well. And then logic apps themselves talk to storage accounts, especially for when we get to talk about stateful logic apps. Just bear in mind that behind every stateful logic app, there's a storage account that's being written to. So the first thing we're going to talk about is stateful versus stateless. So, Dave, do you want to just take us through a little, some of the main points on here?
Yeah, sure. So, if we think of how a stateful logic app works, or a stateless workflow, just looking at the one on the screen here, what's actually happening under the hood is that when a request is received, it's actually being written onto a set of queues in the storage account. And those queues are then being looked at by workers that are running on the compute, and then they're being picked up and executed. And when an action completes, then that state is written back to the storage account, and it's then picked up again, excuse me, by another worker when the next action runs. So you can see that the reason that this is really important is for scenarios where the workflow may be long running. So that maybe there's some kind of process where you need to wait for an event that could happen at some point in the future, or maybe we are talking to some kind of service or database that might be unavailable, in which case we want that to be able to recover in the event of a failure that could happen. And for that retry process to be reliable. So it's very well suited to long-running processes and work or business processes where it's really important that something completes. And stateful workflows do scale out, but the speed of scale out is less than that of HTTP-based scale out, which we'll see in a few seconds. And are we moving on to stateless?
Yes, move on to stateless now.
Yeah, so a stateless one, in contrast to stateful, as the name would imply, just runs completely in memory. So as these actions on the screen are running, there's no persistence going on to storage. So you can get much higher throughput and much lower latency when using a stateless workflow. So if you take the example of a website, for example, where you've got a user and they click a button and it calls a workflow. If that workflow is just reading some data from a database, there really isn't any need for that to be stateful, because we don't need that persistence. And even if we do, then we have to think about what's going to happen with that user if that logic app were to go into some kind of retry mechanism where it might take minutes to complete. The user's probably long gone, and they've just refreshed the page and clicked the button again. So even in that scenario, it may still be beneficial to use a stateless workflow. And with HTTP-based triggers, then because behind logic apps is the function runtime running on essentially premium functions, we have this concept of pre-warmed instances. So when an HTTP request is received, then we have an instance that's ready to go. And as more traffic comes in, then we add more instances, but those pre-warmed instances are pre-provisioned so that when we need to scale out, we can do that immediately. So if you have an HTTP-based request that is executing a stateless workflow, we can get some really good performance by using these pre-warmed instances. And the one thing about stateless is that you don't get run history, which not out of the box, you can enable it, but out of the box, you don't get the run history. But application insights, if it's configured, for that stateless workflow will write to the various tables that App Insights uses, like requests, exceptions, etc. And so you can usually gain the insights that you want using application insights with stateless workflows. And stateful, for that matter, should definitely be enabling App Insights here, but that's a topic for another day.
Okay, so one of the things we've done is taken a workflow. So if we look at this workflow on the right, here's one that Dave put together earlier, and it receives an HTTP request, takes the current time, creates a response, calls a backend service, and then returns the response to the call, all in a synchronous HTTP call. Now this, and we've got two flavors of this. We've got a stateless and a stateful, and we've run this through Azure Load Test to actually apply some load to it. Now, running Azure Load Test does not make great TV. I'll say that right now. So we've in a very preordinate, we've actually gone and got the results first, because we don't need to wait 5 minutes to see a load of instances spin up. So if we look first at some baseline results for HTTP using a stateful logic app. I don't know if you want to chip in on this, Dave, but we've just, on one instance, we've been able to do 36 instances per second on average, but probably over time, as the test's gone on, there's a fairly slow ramp up, and then we kind of peaking almost at 50 requests a second. And similarly with latency, on startup, we're talking getting on for 2.5 seconds, and that latency is gradually coming down to just over half a second, 600 milliseconds. So every workflow is different, but that's just a baseline. Now, if we take that exact same logic app and convert it to stateless, then we've gone from 36 to 125 requests per second that logic app's been able to handle, and the average latency has gone down from over 600 milliseconds to 241. So we've cut the latency by about 70% and been able to almost triple the throughput. So that's kind of just some, just a qualitative thing that you might get on stateless versus stateful logic apps in terms of performance. Do you have any immediate thoughts on that, Dave?
Yeah, with the stateful one, what's interesting is that we're receiving HTTP requests, but because we have a number of actions that need to execute, those are being written onto queues, as I mentioned, and being picked up and processed by workers. So it might be that we need additional compute in order to cope with that additional demand, because remember, a stateful workflow is using queues and storage underneath for good reason. So what we end up with are the HTTP requests coming in that are being serviced, but then in order for the response to go back, we are reliant on those messages or those actions being written onto queues and being processed. And so that can take some time to add that compute in the event that we need to scale out, because it isn't HTTP at that point. Whereas with the stateless workflow, you can see on the right there that the response time comes down really quickly, because we can scale up faster and we don't have any dependencies on workers picking up any other actions. So the only compute that this really needs is satisfied by the scale out of the HTTP requests coming in, and using those pre-warmed instances that I mentioned earlier. Okay, good.
So really, just to summarize, and we're going to do this on this format on a lot of the things in terms of what you may be missing, and then what the takeaways are. But stateful logic apps are really good for resilience and recoverability, because you can resume them when you have an error. You can resume them. You've got a full run history. You know what happened to it, and people tend to use them by default, to the extent that I think a lot of people maybe aren't thinking about stateful versus stateless. but also stateful logic apps. Like Dave said, they're always reading and writing from these queues, and so they're naturally going to be more resource hungry. And with stateless, you don't get the run history, but there's other ways of doing that, such as application insights. And then best practices. I think the first thing is just to think about whether you need things to be persisted or not. If something's happened, like Dave said, if something happened in the HTTP request, does it need to be persisted because you've got a caller there that can retry? Whereas if it's fire and forget, maybe you do need persistence, but maybe in a fire and forget scenario, the latency isn't an issue. So you've got kind of a couple of things there. One of the other things you can also look at is that because a logic app contains multiple workflows, you can actually refactor your workflow so that some of it is stateless and some of it is stateful. So maybe for resilience, you'll kick off a stateful logic app, but actually large parts of the work inside that and the actions inside that can be can be performed by a stateless one, and you just call directly into it. Anything else you'd like to add on the best practices there, Dave?
Yeah, I think what you just said is actually very valid. But if we need persistence, maybe not everything needs to be persisted. And so if you're calling out to an HTTP endpoint, for example, or reading data from a database or something, that could be offloaded to, you could kick off with a stateful workflow, but it could call a stateless one that does that kind of read operation, but then goes back to the stateful to just go and do whatever needs to be done, like, for example, writing to a service or a queue or something like that, where you want that to be guaranteed to happen.
Cool. Okay, so I think we've covered a lot on stateful versus stateless, and that's a really big part of performance. But what we're going to look at next is just a little bit about built-in versus managed connectors. So again, some of the key points really that a built-in connector effectively executes in the same process as the logic app. So it's actually running under your hosting plan on a thread there, whereas the managed connectors, they're actually hosted in Azure on a completely separate process that you connect to them via HTTP. So they're a very, very different, very, very different way of running them. Now, for performance, as you can imagine, because you can auto scale your hosting plan, the built-in connectors will scale naturally with that. But also, if for a lot of our customers, for example, security is a really key paramount concern, and they use a lot of private endpoints and have logic apps talking inside private network, to other line of business systems within the corporate network. Now, built-in connectors can do that because you can have your hosting plan inside that virtual network, whereas a managed connector is never going to be able to talk to inside your network. The other thing is, I mean, Dave, you want to talk a little bit about the sort of the things like the throttling limits and that sort of thing that you get on managed connectors?
Yeah. Also, if you just think back to the consumption tier of logic apps, they are all managed connectors. So it is possible to connect to private resources with some of those using the on-premises data gateway, but it isn't a native VNet connectivity that you get with the built-in ones. And of course, because the managed connectors are in a hosting platform outside of your logic app runtime and your logic app compute, they all have throttling limits on them. And it's worth knowing what they are up front so that you can be sure that your business NFRs are going to be met, because as it says on the screen here, Service Bus has a 6,000 requests in 60 seconds. Other ones have lower throughput. And so what you can find is that you may, if you have fairly high throughput, that suddenly your your logic app or your actions in your logic app are going into a retry loop. And that's because they're being told to retry in a period of time because they've hit a throttling limit. So suddenly something that you think would take a fairly short amount of time can take a lot longer as it goes into that retry loop. Whereas with the built-in connectors, they have no throttling limits. It's completely controlled by the scale outs that you have with the plan and how the logic app runtime is deciding to scale out. So it's important to say that, as it says at the bottom of the screen there, that the managed connectors do actually have a lot of functionality that it would take you a long time to write. So there are definitely cases where they're really valid. It's just that some of them where you might need particularly high throughput, like service bus, for example, where you might be processing millions of records, you really want that to scale out and actually kind of run that logic app at full scale, sending those messages to service bus in order to meet your needs that you would never be able to do with the managed connector.
Yeah, and that's with all these things. Performance isn't absolute. Performance is what does your application need, and then measure it against that rather than, fastest isn't always the best. And so,
sorry, there's
yeah.
one more thing to say. Sorry, the built-in connectors don't have a cost associated with them, where the managed ones do. So it's worth bearing that in mind that if you are using the managed connectors, that there is a per action cost. So it's worth checking that out.
Yeah, whereas because the built-in connectors run, you're already paying for the compute by having your hosting plan. So there's no additional cost for them actually executing. So if performance is a concern, then obviously look at using the built-in connectors where they're available, but also where you are using the managed connectors, just understand the characteristics of them, and just understand that if you are trying to exceed their throttling limits, then that's where you're going to get into some of those scenarios that Dave talked about, that you're going to have retries and you're going to have things just held due to throttling. And so look at what your non-functional requirements are, and then choose appropriately. It's just it's just good design practice to be going through this stuff and knowing where you are with it.
I'll just say one more thing. Sorry, if you do need higher throughput with the managed connectors, it's worth remembering that the throttling limits I spoke about are at the connection level. So if you have one logic app talking to a managed connector, then that throttling is for that connection. But if you had another logic app, then it would get its own throttling. Or if you added another connection into your logic app and you had two, then you would get two, essentially double throughput. I mean, it's often the case that the service you're talking to, whether it's I don't know, Office 365 or Salesforce or something, they will have their own throttling limits too. So it's worth bearing in mind what they are. But by creating multiple connections, you can get more throughput.
Good stuff. Okay, the next thing we'll talk about is a little bit about synchronous versus asynchronous. And I suppose one of the things here is that a bit like in that example we showed before, that when you use an HTTP trigger for a logic app, you receive a request via HTTP. At some point, you send a response. Now, in a lot of, if you're used to writing procedural code, you get to the end of a particular operation, and then you return to the caller. And so a lot of people naturally kind of think that, okay, with the logic app, I'll receive the HTTP request, I'll do my work, and then at the end of it, I'll return to the caller. And obviously, the more time you're doing between the request and the response, the more time that the more your caller is going to have to wait, and the lower the latency of that call. And the more that the slower that call is, the fewer connections you're going to be able to have, and the performance will be apparently worse. Now, one of the things, so some of the things we can do with that is that we can minimize the amount of work we do while that HTTP request is open. So you can actually take a request, create your response, send the response back. That closes the HTTP connection, but the rest of the logic app can continue to actually function. So if the HTTP request is just telling the logic app to do some work, you don't have to keep the request open for it to do that work, and that can actually get you a lot more throughput. And the other thing is you can also have a logic app that writes to service bus. So you might synchronously write to service bus to make sure, yes, I've captured that message. It's on service bus. We've got it. It's now going to be processed, but then we can process that asynchronously. Any more thoughts about kind of around logic apps and service bus, Dave?
Yeah, I think quite a few people don't realize that the connector can take a batch. So I've seen a lot of customers writing to service bus one message at a time, or even in some kind of loop, and we'll get on to loops. But if you send messages to service bus in a batch, it is significantly faster and the performance is way better. And Andrew makes a really good point about sending a response back to the client, because maybe all the client wants to know is that the message has been received and persisted, and that's good enough. And I've seen scenarios too where there's an HTTP request and then it calls some back-end system, and that back-end system isn't really able to cope with the demand of the requests that are coming in which case offloading to a queue, as Andrew said, and then just sending a response back makes real sense, because then the back end can process at the speed that it wants to. So really need to think about what it is that the client needs. And it could be that maybe you send back some kind of intermediate identifier back to the client before it even hits the back end. So if they make a further call, you could use that to tie the two things up.
Yeah, because you could almost have another operation which is like a get status that passes that identifier, and you can go and check on that. Yeah, so there's a whole load of different patterns here that you can employ. You know, you can obviously one of them is sort of the webhook callback thing as well, that allows you to actually give yourself pass back a correlation identifier, and then later on when the work's finished, we call back and tell the originating system that work's completed. One of the things I'm actually going to do now, and this is the thing I'm most nervous about today, is that I'm going to do a demo to just cover some of the batching sides of Service Bus. Now, as we all know, doing a live demo on the cloud whilst doing something live is asking for bad things to happen. But what I've got here, very simply, I've got two different logic apps, and all they do is read off Service Bus, and then they'll store that message in blob storage. And so this one here does single messages. So this is just reading a message at a time off Service Bus, sending it to blob storage. And then I've got a batch version, which is almost exactly the same, but actually this has got the shape of when one or more messages arrives on a topic on Service Bus, and this is set to do up to 100 messages. So we can actually read logic app. The logic app can read in batches and then send those to blob storage. And what I have here is some blob storage. So I've got a blob container for batch, and I've got a blob container for single. They're both empty at the moment. So what I'm going to do now is just kick off a little script that will write 1,000 onto a batch topic. This takes a second to run, and I've got a little console app here that's looking at that. Now, the trigger on the logic app is polling, so in a while it will reach its polling interval and then start to pull those off in batches. So this again, this isn't amazing TV, but as we can see that the logic app is now fired up. It's calling off that batch, and we've got through 1,000 in 3, 4, 5, 6, in about 8 seconds, we've got through 1,000 messages. So that's, that's just because it's almost like the expensive bit is making the connection to service bus. Actually, the number of messages you either read or write. Okay, you read a lot of messages. It's going to be some more work, but there's so much overhead associated with establishing that connection that actually it gives us really good performance to actually think about batching. So what I'm going to do now is, in contrast, is I'm going to write. Let's find the command. There we are. I'm going to do the same thing, but I'm going to write 1,000 messages onto a topic that's being picked up by the single processor. So again, I've got another similar console app here that's just polling that queue. There's the 1,000. So the logic app in this case is going to be picking those up and picking them up one at a time. So at some point we'll get the polling interval, and then we'll start to see how fast that is taking to run down. And there we go. We've hit the polling interval. So you might not be able to see the. I'm going to. Can you magnify this? Text size large. So there we go. So hopefully you can see the numbers on here. So we've got started off at 1,000, and we're working through this, but we seem to be doing somewhere around 10 to 12, 13 messages a second. So it is chugging through that work, but that, we're almost got. So we had 1,000 in about 8 seconds when we were doing batch. So that's like 120 a second versus 12 a second. So we've got 10 times improvement in throughput by just changing that that one shape on the logic app from reading a single message to reading a batch. And so that's just a hopefully that's a good illustration for you as to some of the performance improvements that you can get by going to a batch model. And then there we go. That's still, here we are. We're like a minute later. That's still chugging through that work. It'll do it. There's nothing wrong with it, but we're not getting that level of performance. So it really does make a difference if you're using Service Bus. Service Bus is good because it allows you to process things asynchronously and can have control over rate. But it really does make a difference when you actually are reading that as a batch. Okay, let's get back to the presentation, and let's talk about number of actions. So I think I'm going to let you talk a bit now, Dave, if you're able to, about actions. But but just to kick things off, writing a logic app is not the same as writing procedural code. And so, but do you want to sort of just add a little bit more thoughts on actions, Dave?
And it's not necessarily a bad thing having a larger number of actions, but it's worth bearing in mind that when you have actions, they need to be executed on compute. And so if it's a stateful workflow, then again, we're writing these things onto queues and processing them. And that just means that maybe we need more compute in order to get through those actions. But of course, there are implications of doing that, but maybe that will take a bit more time to provision. If it's a stateless workflow, it's going to take more time to complete from the start to the finish. So definitely worth thinking about the number of actions that you have. And it's not necessarily that you might be thinking, well, the number of actions I have is the amount that I need. And that's not often the case. I've seen quite a few workflows that customers have created that have a lot of undue complexity in them that isn't required. And so definitely worth considering the complexity of the workflow.
I think some of that, again, is just, some of that is just if you've got your mind in procedural code, where you might do where you might do a loop. There are other ways of there can be other ways of achieving the same thing, but certainly looping is like one of those big areas where people can go a little bit crazy and do loops within loops within loops, and then wonder why everything's going really slowly. But there are some other things as well. So parameters versus variables. I mean, that's a big one we see all the time, isn't it, Dave?
Yeah, and parameters actually are great because you can put objects in parameters, and they can be deployed with the logic app through your pipeline or whatever. And then if you want to do some kind of lookup, then you can do that directly through a parameter, and they're really, really quick to do. Just want to pick up on that point actually at the top that we didn't talk about looping slower than parallel execution. If you are, in fact, Andrew's batching example was a really good one. And if, for example, you thought maybe you would create a logic app that starts and then it has a loop, and maybe it goes and reads data from some place, and it then maybe does some transformation, and then it's going to maybe create another message to go and send somewhere. A much, much better way of doing that would be to just rely on the parallelism that Logic Apps has and just point it at a queue, for example, let it run in parallel, pick those messages up in a batch, process them even up, as one, do a transformation or whatever, and then just send it on rather than thinking, I need to think that I'm in some kind of loop and I'm reading messages and doing something with it. So definitely using the parallelism that Logic Apps has is definitely the way to go. And often, if you find yourself in a Logic app, building a Logic app or a workflow, and it is intuitively feeling that it's getting complex, and like Andrew said, you've got loops within loops and appending to variables, and you're bending the workflow to make it do what you want. We have this new feature, it's been out a while now, where you can write custom code, essentially an inline Azure function. So if you can do it in code, just do it in code, because it'll be a lot quicker, easier to understand, and ultimately cheaper as well, requiring less compute. Because sometimes you do need to write a small amount of code. And if you do that in a separate function project, but within the Logic app using this in VS Code, you can do this. That can be a really good option, and definitely code and Logic apps are better together. It doesn't have to be one or the other.
Yeah, good. Absolutely. And the other thing is, I mean, like I say, you've got Logic apps as a functions. The other thing is that if you need to write code, you can put that in a function as well, and call that from your Logic app. But if it's real speed, it's going to be much quicker to execute if you actually call that code directly from your Logic app, because you haven't got that kind of HTTP hop to go and call the function. So again, just be aware of this when you're doing your design. Okay, so we're going to talk a little bit now about how Logic apps scale out. I mean, there's not an awful lot to do this, but ultimately a hosting plan has one or more virtual machines that run in parallel, just like any other kind of web farm application. But some of the things that we kind of think about or that we see is that sometimes people say, "Oh, I've got to set my, my scale out to be 4 instances, otherwise it's going to be too expensive." The thing is, if those Logic apps aren't doing any work, they'll auto scale back down to 1, so they're not going to cost you any more. But when you actually have a lot of work to do, you kind of think the area under the curve is the same. If it takes, if you've got one instance running for 10 hours, it's the same as 10 instances running for 1 hour in terms of cost. So why not set your limits higher, get through that work quicker? Because you can actually, by limiting the maximum number of instances, because you might be worried about cost, you might actually artificially give yourself poor performance when actually there doesn't need to be, and you're actually not incurring a cost penalty by getting through that same amount of work quicker with more machines in parallel. So do bear that one in mind. But the other thing is, and maybe Dave, you can say a little bit about scale up.
Yeah, it's really true that pinning the maximum number of instances in your plan rarely makes sense. And load testing is really important. So if you're building a solution, before you put it into production, make sure that you load test it so that you understand those behaviors and you can understand what those costs are likely to be up front. And actually, a logic app scaling up to 20 instances and running for 10 minutes, the cost is actually incredibly low. And it could even cost you more by pinning the instances because they're going to run longer, because they're going to be retrying, because there's not enough compute to be able to cope with the demand. So it just doesn't really make sense. And so, yeah, we talked about scale out earlier and HTTP having pre-warmed instances. Batch processing is scaled differently, but there have been some improvements there recently to improve the scale out time and how many machines we add when we need to scale out.
Also, just just look at the takeaways of that then. I mean, the thing there is really just, like I say, the main takeaway is don't be afraid of scaling out, because scaling out is actually your friend. And finally, I think this is the last thing we can talk about, but it's about logic apps and workflows. So this actually also has quite a big impact on performance, because again, imagine you've got a lot of different workflows you need to do, and you can put them in one uber massive logic app, and or you can split them up, and you could, if you've got 80 workflows, you could have one logic app with 80 workflows, or you could have 10 logic apps with an average of 8 workflows. But this makes a difference to execution, because when you actually run a single workflow, everything in that logic app is loaded into memory. Whereas if actually some of them aren't being used a lot of the time, they don't need to be loaded into memory, so you can get more memory available for for the ones that actually are executing rather than the ones that aren't. The other thing is that as your hosting plan scales out, just let the underlying Azure services worry about what's running on which node, and let that do the work of being the most efficient at that. So, on the same hosting plan, you've got a lot more flexibility if you break these up. Have you got anything else to add to that, Dave?
Yeah, I've seen this quite a bit, where we have one plan, one logic app, and that logic app has multiple workflows in it that are serving different purposes, if you like, where it might be one workflow is dealing with batch, another one is dealing with HTTP. And in that particular scenario, what you really want is the HTTP request, which might be coming from a website, for example, to be processed quickly. What you don't want is for that to be in the mix with a massive batch process that's processing 10 million records. So
it's like the noisy neighbor thing, isn't it?
Exactly. And in that instance, it might make sense to actually put it on a different plan, even.
Yeah.
But it's worth bearing in mind that logic apps and premium functions, for that matter, and app service scales at the app level, at the scale at the workflow level. So if you have 4 logic apps and one of them needs to scale, it will scale that out across onto multiple machines, but the others aren't loaded. Unless they start executing, which case they can start to reuse that compute that's there if it makes sense. There are runtime decisions that are taking place that will figure out whether or not that can run on the same machine. But it is worth remembering how that scale out works.
Yeah, and one of the other things that we haven't really talked about, but another thing that is also very relevant for that is that this model here, you see here in the diagram, that a logic app points to a storage account. Now, it also means that if you've got one logic app with a massive number of of workflows in it, they've all got to write to the same storage account, and so you're going to get, you can potentially start to get contention on that storage account. Where again, if they are split up and divided amongst separate logic apps, then they each can have their own storage account, so you don't get that same level of contention at the storage or the I/O level. So that's always useful to bear in mind. So there you go. So you can separate your resource-hungry workflows onto separate logic apps, and even separate those onto different hosting plans, and then make sure that you're keeping your storage accounts separate, because that again is a point of contention. Okay, quick deep breath. I think we've covered this. We've been going pretty fast for 50 minutes, so we're going to conclude now, really, and just start to wrap up. And hopefully, we've got a little bit of time to do questions and comments. But just the main takeaways really is that we've talked about Logic App's performance, and a lot of people have experienced issues with Logic App's performance. But performance is one of the things that people often complain about in Logic Apps, but they do give you a lot of other benefits against just writing code. And it's not always all about performance, but and secondly, Logic Apps do perform. And if you understand a lot of the strategies that we've talked about today, the tuning strategies, you can actually get orders of magnitude better. I mean, one of the other examples, just from one of our customers that we've been dealing with, doing a project over the last 6 months, is that they had a Logic App that takes a load of data from web services and tries and processes it in loops. And that was taking a day to execute. But we've refactored that by writing that data into a database, running a couple of queries against it with the Logic App, and it's like 10 seconds. So there are, just by doing a different approach to design, you can actually make, huge orders of magnitude difference. And, very often loops within loops within loops, different approach to design, you can very often make, massive differences there. Okay, Q&A. So we've got loads and loads of things in the comments. Thank you so much for those. I'm just going to have a quick flick through and see if they're. So let's have a look at this one. So Mark is saying, can you cache a response in a stateful Logic App so that if the same inbound message is received, we bypass, for example, a database request? Then if you can do that in a separate cache. So, any thoughts on that?
I think in that instance you would have to use some kind of caching technology, either a lower latency store, or I'm guessing that the thing that you're trying to cache is quite expensive, or maybe has throughput limits or something. So in which case there's no built-in cache in Logic Apps, so you'd have to just reuse Redis or some other service.
I suppose the thing there is that if you've got a stateful Logic App, you can actually store something in a parameter or a variable in the stateful Logic App. But once that Logic App's finished executing, that state's gone. So if actually you need to actually preserve that across executions, then you'd need to cache it elsewhere. Whereas if you were just if you had one Logic App executing, then yes, you could preserve a response in the stateful Logic App over a long-running transaction.
It's worth just noting as well that lots of organizations that use Logic Apps also have API management. And API management has a built-in cache, and it's a reasonable cache as well. And so if you're using that, you can actually just spin up an API super quick, use the built-in cache from API, call it from a Logic App, and you're done. And you've got a really low latency cache that you can use.
I'm just, funnily enough, I'm just looking through the comments further down, and that is exactly the kind of thing that Sandro said. So thank you very much, Sandro. So let's just, this is quite, an interesting one, and this might be something we'll cover off under monitoring and alerting, but very quickly, we talked about not getting the run history, but using application insights. So does that give us the input output of each action in the stateless logic app?
No, it doesn't. But I think and yes, we are going to cover this in a separate session. But it's very straightforward to be able to track and log custom data from logic apps and from other services, for that matter, into application insights that would give you the information you need. And often it's not necessarily that you want to see the whole payload, but maybe you want to pick out an order ID or something so that you can do some kind of customized search. But you can write the payload through track properties in logic apps, yes, but by default it isn't written. But there are ways around that.
Okay, good stuff. Another one we've got here from Mohit: how to use managed connectors in an isolated environment. I think I'm assuming we mean a private VNet, and I think you've kind of alluded to that, haven't you, Dave? That the only mechanism you've really got is on-premise data gateway.
Yeah, I mean, there's nothing to stop you calling them, but if you want, maybe we can take this offline. But if the managed connector, if the thing it's talking to is private, then the only option really is the data gateway if that's supported, or you can open up the firewall walls, which isn't necessarily a good idea there. So there isn't an easy way around that. But it'd be interesting to know which connector it is that you're trying to use.
Yeah, I mean, the other thing is that you may have a logic app that needs to call into your. It depends whether the logic app is sitting in your private network or whether it's sitting outside and needing to call in, because you can also, your logic app can call API management that can then feed through into something in your internal network as well. So there's, again, lots of different options on the design there.
I'm sorry, just one super quick thing on that. And also, it's not necessarily the only option of enabling security, and that is using private networking, because we do have Azure AD or Microsoft Entra ID available to us, where we can protect different resources with OAuth, and that can be a very valid option as well.
So I know we're just going to, we're almost at time, but just last one. How many workflows can we have in a single logic app? Thanks for that question, Rishi.
I don't know what the upper limit is, if there is one, but I think the conversation we had earlier, I'd definitely not have lots of workflows in a logic app. Apart from anything, it's kind of good practice to, if you separate them into multiple logic apps, they can be deployed independently, tested independently, scaled independently, etc.
So although the limit is probably quite high, you might not want to do that. Takes me back. I remember back in the old BizTalk days, I can remember a colleague of mine who'd hit the limit on the number of shapes you could have in an orchestration, which I think was 256, and it was like, at what point did you think that having this many shapes was a good idea before you split this down a bit? So, just there will be a limit, but really just be sensible like that and understand how you're going to balance that workload out. I think that's the key thing there. Great. Okay, so moving on, if we can just have a quick. Oh, someone's already answered this. How would you rate the webinar? Please give us a final vote on how much you've enjoyed the webinar. We've really enjoyed having so many of you on the webinar today. I'm not quite sure what the LinkedIn numbers have been, but we've had really good numbers on StreamYard. So thank you so much. Thank you for so much engagement in the comments. And one of the things we'll say is that we're going to go through the comments after this. Any questions we've missed, we'll be in touch. We'll get back to you. But feel free to to pass on any additional things, send us an email. This is a shared mailbox. It'll go to me and some of my colleagues, and we'll do our best to field your questions. So thanks very much, everyone. Glad you enjoyed it. I think we've definitely pleased a lot of people. So thank you so much, and we'll catch you for the next best practices guide quite soon. All right, thanks a lot, everyone. Bye now.